Dear students, we will learn Cohen-Sutherland's algorithm for line clipping today. Before starting, let's look back at the simple algorithm we learned in the previous chapter. Let's take this case. Let us assume this is the clipping window. Of course, this is x min, y min, and this is x max, y max. Now, if we want to clip this line, according to that algorithm, first of all we find both the points, whether they are inside the window or outside. According to that algorithm, both the points are outside the window. As you can see, if you calculate them, it will be proved that both the points are actually outside the window. And the last algorithm for this case would have been that both the points are outside, so this line would have been rejected outrightly. Whereas you see that some portion of this line lies within this window, so this line cannot be outrightly rejected because it should be partially clipped. This part should be rejected and this part should be rejected, but this part should be accepted. So in such cases, the simple method does not work. Cohen-Sutherland provides solution to this problem. Let's study Cohen-Sutherland algorithm. Before that, whole of the two-dimensional space is divided into regions. I extend the vertical boundaries and the horizontal boundaries also. So this is your clipping window, and I have divided the two-dimensional plane in 1, 2, 3, 4, 5, 6 and 7, 8, 9 regions. Cohen-Sutherland algorithm provides region code for every region. So this region code is a 4-bit code. Each bit can have 0 or 1 value, and the rightmost bit is related to L. This bit is R, B, A. So L means left, R means right, B means below, A means above. Left means to the left of the window. So this portion is to the left of the window. So this is the clipping window, and anything to the left of this will be to the left of this line, and anything to the right of this line will be on the right hand side, and anything, this is the horizontal top boundary, and anything above it will be above the window, and anything below it, below this line, will be below the window. So now every point is assigned the region code. So first of all, let's check what will be the region code for this area. So this area is to the right of the window, so its right column should be put 1, and it is, of course, this portion does not lie on the left of the window. Left is this, so left will be 0. Of course, this is above the window, so above bit will be put high signal, and it is not below, so it will be put 0. So this region will be provided 1010 code. When you are doing it on computer, means you are writing a program for it, it is quite easy to find value of left. So left bit will be 1 if x value of any point, x coordinate of any point, is less than or equal to x min. Similarly, R bit if x value is greater than x max, R bit will be high, and similarly if y is greater than or equal to y max, then below bit will be high, and if y is less than y min, this bit will be high. So this can be achieved very easily. So using these inequations, we can calculate the region code for any point. So any point lying in this region will have this code 1010, wherever it should, it may be here, maybe here, maybe here, in this region. Similarly, the region code for the point lying in this region will be, if you guess, it is on the left, no. It is on the right, yes. It is on the above portion, no. It is on the below, no. So this is the region code for this area. Any point lying in this region will have this region code. And similarly for this area, region code will be, it's on the left, no. On the right, yes. Below, yes. Above, no. Similarly, region code for this will be region code for this area. It is not on, neither on the left nor on the right nor on the below, nor below the window, but it is above the window. And similarly, region code for this will be left, no. Right, no. Below, yes. Above, no. Similarly, for right region code for this, left, yes. This region is on the left of the window. Right, no. Above, below, no. Above, yes. Similarly, for this region code, you will have left, yes. Right, no. Below, no. Above, no. Similarly, this will be left, no. Left, yes. Right, no. Below, yes. Above, no. So, and similarly, the last region, which is most important, this region, left, no. Right, no. Below, no. Above, no. So this region has all zeros in its region code. Otherwise, there are some ones also and zeros also. So now first step is achieved, that that regions are assigned codes. So now when you are given a line, suppose you are given this line, you are given this line, and I take a few examples. Let's take this line. I take 3 lines as example to study. So first of all, whenever we are working on clipping of a line, we will find region code for both of its extreme points. Suppose P1, P2. I'm clipping this line, let us suppose. So region code for P1 is 1, 0, 1, 0. Region code for this point P2 is 0, 0, 1, 0. What you have to do is, you have to bitwise AND it. 0 will be ANDed with 0, will get 0. 1 ANDed with 1, 1. 0 ANDed with 0, 0. 1 ANDed with 0, 0. So this is logical ANDing, but it is done bitwise. Similarly, for this line, let us say P3, P4. P3 point region code is 0, 0, 0, 0. P4 point region code is 0, 0, 0, 0. If you AND it, 0, 0, 0, 0 will be the result. Similarly, let us suppose the next line is P5, P6. Region code for P5 is 1, 0, 0, 0. Region code for P6 is 0, 0, 0, 1. Bitwise ANDing gives you 0, 0, 0, 0. Now we categorize it. First of all, we bifurcate that if a line having 2 extreme points in regions such that their bitwise ANDing is non-zero. If there is at least 1, it may be 2. If there at least 1, 1, then this means that you are to reject it. And this is an indication of line lying outside the window. But if the ANDing is all zeros, then this means that the line has some clash with the window, so you cannot reject it outrightly. So first of all, such cases will be rejected. No calculations for clipping are required. In such cases, you just reject such lines. In case bitwise ending of both the extreme points is 0, that means you have to do some calculations. Here also, in the first category, if region code of both the points is all zeros, this directly means that both the points are lying inside the window and the line is completely inside the clipping window. In such case, also you don't need to have any workout. No calculations are required. You simply accept it as such. Accept the line which has all zeros for both of its extreme points. Now comes the third case. In this case, if the individual region codes are not all 0 but bitwise ending gives you 0, this means that line lies partially inside the window. So here, this is the special case where you have to make some calculations. Here you will find the points of intersection. As we had done in the earlier case, we will find the points of intersection. In this case, this clipping window, suppose this is tried point of intersection with this horizontal boundary, upper horizontal boundary, you will find after calculations that this is the point of intersection and this is the outside point. So this much part of the line will be rejected. And as I told you that you have to try the clipping with all the boundaries one by one. If you try it, you will find no clash. You try the line with this boundary, you will find no clash. And when you find clash with this boundary, you will again find another point of intersection. So in this case, this was the rejected part. Previously, this was the remaining line. In this case, this is the outer point and this is the inner point. So outer point and point of clash will be rejected this time, and the remaining line will be redrawn as this. So using this clipping, we can exactly clip the line. In this case also, you can have this line. For this also, you will make some calculations. You will find the point of intersection and reject this and accept this portion of the line. Here, a special case I want to consider is a line lying in this region. Let us suppose what happens. For this line, first point lies in 0, 0, 1, 0 region, and the other point lies in 0, 1, 0, 0 region. So if you do bitwise ending, you will get all zeros. What does this mean? This means that this category set, according to this algorithm, this line shows clash with window, but actually there is no clash. But this will be resolved once you find this situation. You will find the points of intersection. So first of all, let us suppose you find point of clash with this boundary. You will find this point, not here. This is the point of clash with this boundary. So you will reject it. In the remaining line, for the remaining line, you will find point of clash with this boundary. Means this line will be now outrightly rejected at it is completely outside. This will be a case like this, and this line will eventually be rejected at all. I expect that you try some numericals based on it for a more clear picture. Thank you very much.